All right, for domain, we are looking at some rules. At first glance, it looks like we're just using the log rule. However, this tangent has a hidden division. Remember that tangent of x is sine of x over cosine of x. So we have two things that we need to pay attention to. First of all, we're dividing by cosine. So cosine of x cannot equal 0. The other thing we have is a natural log of tangent x minus 1. And for natural logs, the input has to be greater than 0. All right, well, let's talk about this. First of all, cosine of x cannot equal 0. Well, that means that x cannot equal pi over 2 plus pi times n for n an integer. Okay, we should be used to this information from the unit circle. And then we've got here tangent of x minus 1 has to be greater than 0. In other words, tangent of x has to be greater than 1. And we need to figure out when this happens. So first of all, notice it's positive. I'm actually going to draw a quick unit circle just so we can get some intuition about this. So tangent is equal to 1 at pi over 4 and at 5 pi over 4. Okay, now, before we hit pi over 4, also notice that tangent is going to be positive because it's greater than 1. So tangent is only positive in the first and second quadrants. It's negative in the second and fourth. So we know we're got to be in the first or third quadrants. And it needs to be bigger than 1, which means sine of x over cosine of x has to be greater than 1. Or sine of x has to be bigger than cosine of x. Meaning the y-coordinate on our unit circle has to be bigger than the x-coordinate. And so that happens up here. Okay. And down here. Okay, those are the portions that we care about. Of course, it has to be strictly greater than 1, so we're not allowed to include those endpoints. And of course, tangent is not even defined, and cosine is not allowed to be 0, so we can't include those. All right, so there's our visual representation of our domain. Let's go ahead and write this out algebraically. So we're looking at the set of all x's that are real numbers, and we have to satisfy the condition that we're in these spots. So we'll say that x is between pi over 4 and, well, I'm going to have to change this, and pi over 2. Okay. But of course, that's just in the first revolution here. So it's really every 2 pi after that. So I'm going to add a 2 pi, and actually notice if I just add pi, I get the starting point there. So I'm going to add plus a pi n, and then pi over 2 plus pi n, where n is an integer. Okay, so for a given value of n, my starting point of my interval is pi over 4 plus pi times n, and my end point of the interval is pi over 2 plus pi times that n. And so there's my domain for this function.